Okay, so 11.4 is volume of a sphere. We're also going to look at surface area of a sphere too. But the volume of a sphere formula is right here. So 4/3 pi r cubed. So if we're doing a hemisphere would be half of that, which is 2/3 pi r cubed. And that's the trick, is to remember that r is cubed, okay, and not squared. So we're going to find the volume of these three figures. So volume of this hemisphere is 2/3 pi r cubed, and r is 10. So we plug that in, and we get 2,094.4 meters cubed. Volume for the cylinder is the area of the base, which is a circle, times height. So pi 10 squared times 10 gives me 3,141.6 meters cubed. And we haven't looked at the volume of a cone, but we will learn on Monday that it's 1/3 area of the base times height. And the base is a circle, so 1/3 times pi r squared, and then the height is 10 also. And we get 1,047.2 meters cubed. So if we find the volumes of these, which we did, and then it says, what do you notice? Well, this is about twice the volume of that one. And this is about 3 times the volume. Now we want, it says they want to cover that surface of the ball with metallic fabric. So what is the minimum square meters of fabric that the club needs? Well, we haven't learned surface area, but I'm going to give that to you. They give us volume, but they don't give us radius. We need radius. So the first thing we're going to do is think about volume of that sphere is 4/3 pi r cubed. And they gave us volume, so we're going to put that in, 1.8. And we're going to solve for r. Now, the first thing that you can do is multiply. You can multiply these two together. And that is 4.18. So 1.8 equals 4.19, actually, if you round it. Okay. And then we're going to divide each side by 4.19. And we get 1.8 divided by 4.9 gives me 0.43 equals radius cubed. And then we're going to take the cubed root of it. And I need to show you how to do that on the calculator. If you don't know, ask somebody. And if I do that, I get r equals 0.75. All right, so the surface area of a sphere, which we're going to need for the, and I write it again later in here, is 4 pi r squared. So 4 pi times 0.75 squared. And you're given both of these formulas, volume of a sphere and surface area of a sphere, on the AOC. Okay, so what is the volume of a hemisphere? Okay, and I've left this on here even though I've talked about it because of the great circle. The great circle is this intersection of the sphere and a plane containing the sphere. So it divides the two hemisphere. Okay, it's the flat part of this hemisphere. That's what we call the great circle. All right, so find the volume of the sphere. So volume equals 4/3 pi r cubed, and r is 3.7. And we get, excuse me, 212.71 inches cubed. Now I'm not going to write the volume for anymore because I don't have a lot of space. Write the formula. So volume is 4/3 pi r cubed. And you should get, now you're going to have to, 696.91. You're going to have to stop this and do these problems a little slower, okay? So you can put them in your calculator or write them down. Okay, so now look, this one is a little different. It tells us the circumference of the great circle is 14 pi. It doesn't give us radius. So the first thing we have to do is find radius. And if you think about circumference, it's 2 pi r. And if we put 14 pi in for it, so we get 14 pi equals 2 pi r. Now the pi's cancel each other. And if you divide by 2, we get 7 equals radius. So the volume is 4/3, because it's the whole sphere, pi r cubed. We'll multiply that out. We get 1436.76. Now, I want you to stop and see if you can do these, and then come back and check your answers and your equations with mine. Okay, so you got all of them up there. You can stop this and look. That last one, we had to use area to find radius first. So make sure you understand that. And then let's move on to this. This is a composite figure. It means it's got several. So we're going to find the volume of it. So the first thing we do is find volume of the cylinder. And we're going to add that to the volume of the hemisphere. Okay, so volume of the cylinder is pi, area of the base, let's write that, area of the base times height, which is, the base is a circle, so pi r squared h, plus the volume of the hemisphere, which is not 4, but 2/3 pi r cubed. So I have pi, r is 1, h is 3, plus 2/3 pi, and r is 1 again. And this would be 9.425 plus 2.094 for a volume total of 1152. Okay? Now, let me just add them together. So this one's a little different. It says, what's the volume of the space between the sphere and the cylinder. So think if you had a can and you dropped, a golf ball in it, or a paint can, you put whatever. Now, I know it's hard to tell, but this can is only as wide as the ball. It reaches it, okay? So, which means the height is going to be 24. It's kind of hard to discern that in the picture. But that ball fits evenly all the way around. So what we're going to do is find the volume of the cylinder. And if you would drop a ball into a can and it was full of water, that water is going to come out, right? It's going to lessen the volume. So what we're going to do is then subtract the volume of the sphere. Okay, so volume of the cylinder is area of the base times height, and the base is a circle, minus volume of the sphere, which is 4/3 pi r cubed. And radius is 12. And the height is 24. And then radius is 12 again. If you put that in your calculator, you should get 10,857.34 minus 7,238.23. And if you subtract them, 3,619.11 cubic centimeters. Okay? All right, just a few more. What is the volume of a hemisphere with radius 3? So volume of a hemisphere is 2/3 pi r cubed, which is 56.55 cubic feet. And then what's the volume of a hemisphere with a diameter? Well, volume is 2/3 pi r would be 6.5 cubed, which gives me 575.17 centimeters cubed. Okay? Now remember, this first one says surface area. And remember, surface area is without the cubed. So no 3. So no 4 divided by 3, just 4 pi r squared. The first couple of problems were about the surface area. And there you have it. You are doing the homework, and I will see you on Monday.